Our lesson today is a review of rational numbers. You should recall the set of integers from our last lesson. The set of integers is formed by the natural numbers, including 0, together with the negatives of the non-zero natural numbers. Integers can be written without a fractional or decimal component. Is the set of integers closed under division? Try to find a mathematical proof that will support your answer. I hope that you were able to come up with the correct answer. No, the set of integers is not closed under division. Let us use 2 divided by 3 as an example. The answer to 2 divided by 3 is not a whole number. Therefore, it is not found in the set of integers. 2 divided by 3 gives us a new number which can be denoted by the fraction 2 over 3. This is called a rational number. Any number that can be expressed in the form a over b, where a and b are integers and b is not equal to 0, is called a rational number. The set of rational numbers is denoted by q. Since b can be equal to 1, the set of rational numbers includes natural numbers, whole numbers, and integers. This is because 5 and -9, for example, can be written as 5 over 1 and -9 over 1. The set of rational numbers also includes terminating and repeating decimal numbers. For instance, 0.25 can be written as 25 over 100. This fraction can be further reduced to 1 over 4. We will learn more about writing, terminating, and repeating decimals as fractions in the next lesson. I am sure that you thought of many interesting and practical ways to use rational numbers. When you are baking or preparing a meal, the recipe often calls for partial measurements, such as 3½ cups or 2¼ teaspoons. You may have also thought of the marks that you receive on tests and quizzes. These rational numbers show how many questions you answered correctly out of the total number of questions. Perhaps you thought of rational numbers that show proportion. For instance, the number of female students in your class out of the total number of students is expressed as a rational number. If there are 9 girls in a class of 15 students, the proportion can be expressed as 9 out of 15. One important property of rational numbers is that many rational numbers can represent the same number concept. Let us look at these rational numbers, students. 1 over 2, 2 over 4, 3 over 6, and 4 over 8 all represent the same concept. 1 over 2 is the rational number in its simplest form. When a rational number is expressed as a fraction, it is often expressed in its simplest form. A fraction A over B is in simplest form when the greatest common factor of A and B is equal to 1. One way to reduce a fraction to its simplest terms is to use the factorization and cancellation method. In this method, both the numerator and the denominator of the fraction are expressed as their prime factors. Then, common factors are cancelled out, and the factors that remain form the simplest form. Suppose we have the rational number 25 over 40. 25 can be expressed as 5 times 5. 40 can be expressed as 5 times 2 times 2 times 2. Since both the numerator and denominator have a factor of 5, we can cancel this factor. We are left with 5 over 8, which is the simplest form of this rational number. Hello, students. I am sure you had no difficulty with this activity. Please compare your answers to these. 16 over 72 can be expressed as 2 over 9 in its simplest form. Negative 12 over 60 can be expressed as negative 1 over 5. 15 over 45 can be expressed as 1 over 3. Finally, 24 over 9 can be expressed as 8 over 3. You may have noticed, students, that 8 over 3 is in the form of an improper fraction. In an improper fraction, the numerator is larger than the denominator. An improper fraction can also be expressed as a mixed fraction. 8 over 3 can be expressed as 2 2/3. Both improper fractions and mixed fractions are rational numbers. Today, we have learned to describe the set of rational numbers, and we have learned how to write rational numbers as fractions. We have seen how fractions are expressed in their simplest forms by using factorization and cancellation. In our next lesson, we will study the representation of rational numbers by decimals.